All right. Okay. Like I said, we are going to start on magnets. Today is actually our first lesson on magnets, and I was just checking with the rest whether or not they've learned it. Even if you've not learned it, it's fine. Okay, just take it as you learn it in advance ahead of your school. Eventually, we will definitely be covering all the topics required for your end of year exam, so you don't have to worry about that. Okay. Okay. So what about magnets? A few house rules, I think, for Jack and Tasha. Okay, you are supposed to rename yourself as your real name because I will be taking attendance. So, like for example, I believe Jack, for your Zoom account, James is probably your parents' name, right? So it'll be good if you can rename yourself as Jack. Tasha, you've renamed it. Very good. Abir, Ariano, and Kelvin as well. Okay, next thing that you need to do, one of our house rules is that you have to turn on your video, which I think all of you have been doing a good job so far. Yeah. Next thing is, if you have questions to ask, you may type it in the chat. Yeah. Okay. Occasionally I will check the chat to see who has, typed something in. But if let's say you have a very urgent question, you have a burning question to ask, you can always click on the raise hand icon. Maybe I'll just demonstrate to you once. Okay, so there's this part on reactions. Click on reactions and then you can just raise your hand. Okay, so the moment you raise your hand, you will be prioritized to the front. And when I see that, I can call upon your name to answer a certain questions. Okay, or if let's say you have a question to ask, you can also raise your hand. Okay, are we clear about that? So if let's say you really need to go toilet, just go ahead. I can't stop you from going toilet because I understand you need to answer to nature's call. But I wouldn't be expecting you to go toilet too often, because our lesson is only 1.5 hours. So you shouldn't be going to toilet too often. Okay, maximum, I think is twice the most. Yeah, unless you're having a diarrhea, which I think if you're having diarrhea, then you probably should go and see a doctor for that. Okay, and I think all in all, yes, Ariana, you have a question?
Can I go toilet?
Yes, go ahead. See, so that's how you ask a question. Ariano has demonstrated that to all of us. Okay, and all in all, basically just be respectful to one another, right? Because this is a cyberspace. I think it's only nice if we can just respect each other. The reason why I ask you to mute your microphone is because unless you're answering a question, it's because if all of you were to turn on your microphone, then the background sound is very disruptive. So everybody else, when we want to focus on certain things in class and you turn on the video, I turn on your audio, it's going to be very disruptive if there's a lot of background sounds behind. Okay? Okay, no questions. I'm going to move on. Now we are going to fill in the blanks with regards to magnets. Actually, for this topic, there aren't that many concepts. Okay, so let's just go through one by one first. Okay, we take it slow. Magnets are special objects that pull objects made of what? Okay, so when we talk about a pull, it's actually it's actually an attraction. So that attract. Okay, magnets are special objects that attract objects made of two words.
Metal.
No, not necessarily metal.
Magnetic material.
Very good. Well done. Okay, because not all metals are magnetic materials. The magnetic materials are actually what we call the science is not cool. Okay, so what do we mean by science is not cool? Science is not cool basically is your steel.
Steel, iron, nickel, cobalt.
Very good. Okay, who was it just now? Kelvin, is it? Yes, and you say you have not learned magnets, but you know about this. That's great.
I
Okay.
didn't know. I learned it in school.
You learned it in school. Okay.
Yeah.
Nice. Yeah, so your school is not cool. Basically, it's your steel, iron, nickel, cobalt. Why is the answer not metals?
Hello.
Because
Because aluminium cannot.
Hello.
hello, yes. Hi, James.
Uh,
Oh,
we're
sorry.
just
Hi.
testing the microphone.
Okay,
And we
yeah.
cannot change the James name into my name.
Oh. That's fine. That's fine, actually. Maybe the next lesson onwards, you can change it.
So the rest of this so much.
Okay. Right. Okay, we're going to continue with our content. Yeah, so we were talking about magnetics materials. So we remember it. I think it's an easy way to remember an acronym. School is not cool, or science is not cool. Basically, it means steel, iron, nickel, and cobalt. These are the examples of your magnetic materials. The key thing to note is that not all metals are magnetic materials. Okay, not all metals are magnetic materials. So some examples would be mainly steel and iron. Okay, so of course there are different types of magnets, like for example, your circular magnets, your U-shaped magnets, which is also known as your horseshoe magnet. This magnet, bar magnet is very common, right? Needle magnet is usually found in your compass. And then lastly, your ring magnet. So these are some examples of your magnets. Okay. A magnet can what magnetic materials?
Attract.
Very good, Jack. Okay, a magnet can attract magnetic materials. A magnet has how many poles? Two. Yes, I see Arano doing this. Yes, two. Okay, I might just have to remove the annotation because, like I said, your annotations will not be saved. I think it's because it's a Zoom thing. Yeah. So that's that. Okay, so I'll just write it down for you. They have two poles, specifically your north and your
South.
south. Good. Okay. A freely suspended magnet always points in the what direction?
North
Is it just north?
and south.
Yes. So we always write hyphen in between. It always points in the north-south direction with a hyphen in the middle. Okay. A magnet can attract and what? Another magnet repel. Now, how do we confirm if something is a magnet? Only if it repels one another. Then we can
Because
say that both are magnets, right? Yes, Kevin, you want to say something? Mhm. Now, if they do not repel, they attract, then maybe one of them is a magnetic material. Okay? The attraction of the magnet is the what at these two poles. Starts with letter S. ST. R. Yes, Abir.
okay,
Close, very close. They are the strong.
the
They are the strongest. Yes, they are the strongest at these two poles, right? They're the strongest at the north and the south pole of a magnet. So let's take a look at the first question. Okay, if you want to answer, please raise your hands. Yes, Abir. Which of the following materials? Steel. Very good. Because if you want it to be attracted by a magnet, it has to be a magnetic material. Okay, and remember, let's just quickly recall your magnetic materials. Science is not cool. Steel, iron, nickel, and cobalt. So these are your magnetic materials, not all metals, yeah? Question 2. 3 iron rods are made into electromagnets using the setups. Which of the following shows the arrangement of rods in descending order? Descending means in terms of strength, it will then be from the strongest. Descending means it's going down. So it's strongest to the weakest. So which of these setup will have the strongest magnetic strength? Someone? Anyone? Oh, Kelvin.
B.
B for boy. Okay, let's see. Okay, the difference okay, actually all three circuits, right, have two batteries, right? Can you see? Two batteries each.
But the amount of coils wrapping around it is like different.
Yeah. So the difference is
The more there is, the stronger it is.
yes. So I would say for this experiment, the change variable, what are we changing is actually the number.
Of coils
Yes, the number of
that
coil around the rods, right? Around the iron rods. So one thing, the concept is that the more coils, the stronger the magnet. Okay, so in this case, of course, the strongest is Z, followed by X, then Y. Right? Z, X, and Y. Very good, because this one is the most. So this is 1, 2, 3. Okay, so basically this is an electromagnet, and usually this is the way that we actually make it into an electromagnet. We allow the electric current to flow in a circuit. Yes, Abir, you have a question.
Also, you can use the stroking method.
Correct. So two ways to make a temporary magnet, stroking and the electrical method. Okay, we'll talk more about that later on when we encounter another question on stroking. Yeah? This is the one. Yes. So Casper tried to magnetize a steel nail using the stroke method as shown. After stroking 15 times, he used the nail to attract some steel pins. The 3 pins were attracted. He repeated the experiment with another similar steel nail. Okay, so the question is, what should he do if he wanted to attract more than 3? Okay, so my question here is, when you stroke this one, what is the pole here and what is the pole here? What is the pole at A? Is it north or south?
no.
North, very good. Okay, because you are touching here with north, so when you stroke, it's just like you're patting your head. If you tell yourself, I'm clever, I'm clever, I'm clever. So you would think that you are clever because it's the Pygmalion effect. Okay, so same thing for the magnet. So north, north, north. So this part will be north. The other side will be south. Okay, so if you want to make it attract more paper clips, what should we do with the method?
Stroke more
Abir.
than 50.
Okay, you have to raise up your hands first, okay? Abir?
Stroke more than 15 times.
Very good. Yes, the more strokes you have, the stronger the temporary magnet. Okay, we do not call this the electromagnet because this is not created by running electric currents. Okay, so we call it a temporary magnet. Yeah. Okay, next one. Gilbert placed some magnets close to each other. In which setups would the magnets have the strongest repulsion? Who would like to answer this? Kelvin, no? Don't want to answer? No? Yes? Okay, Kelvin, can you try?
A.
Why is it A? Can you explain?
Because both the poles are facing and the south, and they will repel.
Yes, because these two are like poles and like poles repel. Of course, the
And
opposite
like
would be
poles attract.
good. Okay? So if you say like poles repel, then these two also like poles, ma. How come they are not the strongest repulsion?
Because all of them are in the middle part, like it's slanted.
Yeah, it's slanted. It's not directly actually. Because if you look closely, this end is actually to the middle, so it doesn't really have a strong. It has repulsion for sure, but it's not the strongest.